Anyways, hi, welcome back to Algebra Jail. And today we're gonna be working with radicals. Yes, they're fun, they're easy, and you're gonna do them, and I have to do this really quickly, so yeah. Hello everyone, we're back in Algebra Jail, of course, and today we're gonna be solving this radical. So we have this radical right here, and we need to solve it. Or maybe you need to solve it. You don't know how to solve a radical, so I'm gonna tell you how to solve this. Like, we couldn't get an easier one? Yeah, okay. Anyways, so firstly we're going to identify. Look at all of this. What is going on here? It's a lot going on here. So we have our very large radical, and it's breaking a few rules. See, when working with radicals, we have a couple of rules, and this one breaks it. As you can see, we have 11x to the third power over 72, and this whole entire equation is put into a radical, period. So this is not good, and more specifically, it's breaking our first rule. The entire thing, this entire equation should not be inside the radical, or the radical. If anything, it should be 11x over 3, which is inside the radical, but it's not. Instead, we have this whole equation, and that breaks one of our math rules, of course. So the way we're going to fix this is by splitting it up. How do we split up? Well, it's easy. We're just going to convert the equation to look something like this. So we have 11x to the third power. This should not be so big. Hold on, let's fix this. There we go. And then we're also going to write this radical right down here as 72. So there. Now we have a better version of what this was. This is good. We want this. We don't want this as much as we want this, but this is what we want.
You don't want to be like this. This is disgusting. This is awful in every way. If I could kill it, I would. But I legally can't. But I've considered it.
Now that we have our new version of the radical right here, let's identify it again, okay? Let's see what's happening right here. Yeah, it's breaking another rule. We can't even work with this until it's like fully fixed, okay? And the rule it's breaking is number 3. There can be no radicals in the denominator. The denominator is the bottom number of the fraction, which this is what this is. So there can be one in the top, which we have one right here, but there can't be one right here. So what are we gonna do? Well, we're gonna simplify this. We're gonna fix this. We are gonna fix this. Okay, firstly, let's start off with simplifying this top, just because I want to do the top first, because this brings a lot of confusion here. So let's get the drawing tool out, and we're gonna write 11x to the third power, right? And then we'll have our bottom equation down here. But let's focus on this up top right here. You're gonna do the bottom anyways, but we're gonna do the top first. So what we have right here is 11x over 3. And right now we don't have an index for it. The index is the number outside of the radical, this whole equation. And so we're gonna fix that by kind of rewriting this, but we're gonna break it up some. And when I say break it up some, we're gonna literally break this up. So we're gonna distribute one of the x's, which will give us x to the second power, and we're gonna leave 1x out here. Okay, now when doing this, we kind of have to rewrite it since this is like a whole equation now. So let's go back and let's rewrite. I'm gonna distribute the 2 instead. Put it on this side just because I just realized we need to change that up some. So we're gonna have it like this, right? And while it looks like that, we can now break this up, so we'll have two equations. So, there we go. We get x over 2 times (11x). Boom. Would leave us with just x. Why? Because we're getting rid of one of the 2's, which give us just x, and then that will be written as x, and then 11x inside the radical. So then we're going to work on this 72 right here. So that is very sloppy. So we have 72 right here, and we need to break this up. Now, the way we're going to break this up is by creating a little number chart over here in this nice, very nice corner, actually. And how we're going to do this is by taking this, and we're going to see what equals what. So we can pull out some prime numbers right here. So what times what equals 72? Now we're going to use 2, for example. 2 times 36. And then we have 2 times 36 gives us 72. And then we need to figure out what times what equals 36. Why? Because we have to kind of keep going, just because this is like still a very large number, and it can easily just like keep going and it being divided. So that would be 6 times 6, which would give us 36. And then we have to figure out 6 times 6 and 6 times 6. We know that 2 times 3 gives us 6, as well as 2 times 3 on this side. And then what we're going to do is we're going to pull out the prime numbers here. So we have 2, 2, 2, 3, and 3. We can write this as 2. That is a z. 2 times 2 times 2 times 3 times 3. Better yet. And then what we're going to do is we're going to pull out the prime numbers here. So we have 2 times 3 times 2 times 3. And we're also going to make sure we circle these. So we're kind of like pulling that out, right? And we're going to be pulling out a set of numbers that equal the same amount as the radicand. Now for that it's x, but we're going to use 2 anyways, just because we have all of these 2's, right? So set 2 3's, set 2 2's, and then we have 1 leftover 2. And that leftover 2 is actually going to go inside radicand right here. The leftovers always go inside right here, and then our 2 numbers over here, 2 times 2, 2 times 3, those both give us 6, and specifically 6 to the 3rd power. Specifically 6 to the 2nd, actually. So there we go. And then what we're gonna do is we're gonna get rid of this for right now. And we're gonna work on going a bit further with this. So we're gonna multiply fractions, and we're actually gonna multiply the numerators and denominators separately by a radicand of 2, because we actually need to get rid of this right here. See this? We gotta get rid of it. So 2 times radicand of 2 times the radicand of 2, and then whatever we do to this side, we do to this side, of course, times 2, right? So there we go. So now we're going to do let x times the radicand of 2, which would actually give us 22x. Why is that? Because 2 times 11 is 2. So we get 22x x for the top, and then 2 times 2. The radical 2 kind of cancels it out, this and this, so we just get 6 times 2. And then we're left with this down here, also a very weird looking 2. 6 times 2 is going to give us 12. And from there, we can't really do much with it, so we rewrite the equation as x 22. That is a very weird looking 22. 22x over 12. And that should be your finished equation. Pretty simple. Very simple. This is very, very easy. And yes, we love math and very easy, very simple stuff.